All right, today we're going to pull back the curtain on a technology that's, well, it's changing everything, machine learning. But we're not just going to talk about it in the abstract. No, we are going on a quest, a journey, to see how a real-world model actually gets built, right from the ground up, step by step.
I mean, just stop and think about that for a second. In what feels like the blink of an eye, machine learning has gone from something out of science fiction to this invisible force that's a huge part of our daily lives. From your spam filter to your voice assistant, it's just everywhere. So that's the big question, right? We all see what it does, but how does a data scientist actually take a business problem, grab a bunch of raw data, and magically turn it into a predictive model? To figure that out, we're going to follow along as we build a model to predict housing prices in California. So let's start this quest.
You know, every machine learning quest, it doesn't kick off with fancy code or tons of data. Nope, it starts with a simple question. What's the goal here? What's the business objective? For our project, we've got an investment company that wants to figure out if an area in California is a good place to invest. Our model's job? Predict the median housing price for any given area. Now, this is super important. Our model? It's not some island. As you can see here, it's really just one piece of a much bigger puzzle. Its predictions, the district pricing, get fed into this larger system that makes the final call on the investment. This whole thing, this whole workflow, is called a machine learning pipeline. And it really shows you why our model has to be as accurate as possible.
Okay, so we've got our mission. Now what? Well, now we turn to the single most important thing for any data scientist, the data. If this whole thing is a quest, then the data, that's our map. It's going to tell us where we are, where we can go, and what kind of treasure or dangers might be hiding along the way. And boom, here it is. This is our map. It's a look at the 1990 California census data. Each little dot is a district, and you can immediately start to see patterns, right? Look at how the red and yellow dots, those are the expensive spots, they're all clustered near the coast, especially around LA and the Bay Area. And the bigger circles, they tell their own story, showing us where the most people live.
So, what does that cool-looking map actually look like to a computer? Well, it looks like this, a big table of numbers. Each row is a district, and the columns are clues. In the ML world, we call these features. We've got things like location, age of the house, median income, all little breadcrumbs that might help us. But that last column, median_house value, that's the special one. That's our target. It's the answer we want our model to learn how to predict. But, of course, no quest is that easy. The path is full of, well, let's call them data dragons. These are really common problems that can totally wreck a project if you're not ready for them.
So let's meet the first dragon. And trust me, this one is maybe the most dangerous of them all. What happens when your map is just plain wrong? When the data you're using to navigate doesn't actually match the real world? This visual just perfectly nails the problem. That dotted line, that's a model trained on a pretty limited set of data. And it suggests a really simple rule. The richer a country is, the happier its people are. Simple. But then we add more representative data, the red squares, and we get the solid line. Whoa. The reality is way more complicated. Our first model wasn't just a little wrong, it was dangerously misleading. So that dragon, it has a name. It's called sampling bias. It is the critical mistake of building your model on a skewed, unrepresentative slice of the world. Because if your training data doesn't look like the real world, your model is going to get a rude awakening when it finally gets out there. It's the classic saying, garbage in, garbage out. All right, on to the next beast. Take a look at that dotted line. This model has learned the training data, the blue circles, perfectly. I mean, it zigs and zags to hit almost every single point. But the moment we show it some new data, the red squares, it's completely lost. It's way off. See, it didn't learn the real pattern. It just memorized the noise.
And this brings us to a classic two-headed dragon, overfitting and underfitting. An overfit model is way too complex. It's like that student who just crams and memorizes every answer for the test, but has no clue what any of it means. And an underfit model, that's the opposite. It's too simple. It's the student who didn't study at all. Our job is to find that sweet spot right in the middle.
And the last big challenge? It's just that real-world data is, well, it's messy. It's never perfect. The solution is this mix of art and science called feature engineering. It's an art because it takes creativity, like guessing that the number of rooms per household is a much better clue for our model than just the total number of rooms. It's all about crafting better, smarter clues from the raw materials you have. So, how do we fight back against all these dragons? Well, it's not about one magic spell or some super complex algorithm. No, it's about forging a weapon, a strong, repeatable, automated process.
We build a data pipeline that takes our raw, messy data and systematically turns it into something clean, organized, and ready for our model.
So this pipeline has three main stages. First up, we clean the data, finding and dealing with any missing values. Next, we transform our features. A model doesn't understand words like nearby, so we have to convert that text into a number it can work with. And finally, we scale all our numbers. This is absolutely crucial. It stops the model from thinking that a big number, like the total number of bedrooms, is automatically more important than a smaller, more meaningful number, like median income. Okay, our data is clean, our pipeline is built, our model is trained. Now, it's time for the final exam. We have to find out how well our model will actually do in the real world, on data that it has never, ever seen before.
And this is how the pros do it. Before we even write a line of code, we split our data into 3 piles. We use the training set to teach the model the basics. We use the validation set, or dev set, to tweak it and pick the best version. And the test set, we lock it away in a vault. Seriously, we don't peek, we don't touch it until the absolute very end. This is the industry standard for a reason. It keeps us honest.
And this is the absolute golden rule. Using that test set to help you tune your model is like giving a student the final exam questions a week before the test. Sure, they'll get 100%, but it's a completely fake result. That test set has one job, and one job only, to give our model its final, unbiased grade.
So, after all that work, we unlock the vault, and we let our model see the test set for the very first time. The result? Our model's typical prediction is off by about $41,500. Now, that's not perfect, but it's a huge improvement. For some context, the estimates that human experts were making at the time, they were often off by as much as 30%. So our model provides a much, much more reliable starting point.
And just like that, our quest comes to a close. Let's recap what we did. We started by framing the business problem. We explored our data map. We slayed those data dragons like sampling bias and overfitting. We engineered better features. We forged an automated pipeline. And finally, we gave our model its final exam on an untouched test set. That right there is the end-to-end journey of a real-world machine learning project.
But here's a final thought to leave you with. We built the model. It works great today. But what about tomorrow? The housing market is always changing, new data is always coming in, and models can go stale. Which leads to the real question. In a world that never stops changing, is a data scientist's quest ever really over?